Yesterday we have started the work of linear regression, right? And you got that means all the process. You got the major point related with the linear regression, what is the backend process and all, right? And you know what? Today I will implement another one multiple linear regression point, and side by side we can do the one thing as well. Means working working of logistic regression, because we have to know everything related with the classification as well. So classification problems as well as the linear regression, the way we have discussed yesterday as well, some problems means how we got that problem, how we can solve the problems as well, all the things. And now I will implement the multiple linear regression. Okay, process of that whole concept. Um, I'll take one project as well in multiple linear regression. Even we are going to discuss about some structural point. Means I think previously we have discussed about imbalancing, right? Is it correct? Imbalancing. Do you know the imbalancing cross validation concepts? Why we got that problem? Why we are getting these problems? So these are the things now we are going to work on it, right? And once we get know all this study and structural point, then definitely you will enjoy the machine learning parts as well, right? So let's go for the yesterday, where we have worked on the one project. Okay, so that is an 50 startups. So at the end of the process, means the first part we have covered that R&D, administration, marketing, spend, state, and profit is in, we are going to find out the profit as well. And the major thing is related converting the state column. With the state column we have done the label encoding, means one hot encoding. So then we entered into the process of this. So I will tell you everything. Just a minute. So I think we should go for uh, this part. Okay, entering into this part. If suppose if I want to go for linear regression, we have passed theta, extreme, y extreme. Okay, not an issue now. We got it easily because linear model we have to use. It doesn't matter that we go for if suppose simple linear regression or multiple linear regression, you should have to use the linear model only to implement what to implement linear model, means linear regression concept. So let's check out one thing. So tell me, you got the point related with the linear regression, how the linear regression works, how the processes works, how the intercept, what is the meaning of intercept, what is the meaning of slope. Even we have discussed about how the observational values will go there, how the comparison with the values will applicable there. Okay, so not only we have discussed about logic, even we have implemented as well, right? So even we have discussed about, if suppose how much data we can pass into the model, means not only 80-90%, even we can pass it the 100%. But if we pass the 100% of data, definitely there is some kind of drawbacks we got there. So better to pass all the data. You can go for the some limited data as well. So now the way, first I will implement this one. Okay, execute this one. You will get to know about the processes. Okay, so Now check out. So can we go for without? Suppose yesterday what we have done, we we have worked with the state column, means with the state column. Without state column we haven't gone through that. Are you getting my point, what I'm trying to say? With the state column we got it some sort of our profits system, right? And even, can you tell me what is the life cycle of machine learning now? The way we have implemented, the life cycle never changes. Life cycle is nothing but the way, suppose software life cycle is there, the agile module, or suppose waterfall module is there, right? So similar kind of that, machine learning also has an life cycle. In the interview sessions, what are the steps that have for the execution of the any project? So what are the steps, can you tell me steps related with the life cycle? Already you know that. Anyone, please? Importing library first. Second, data set, adding a data set. See, slicing into the independent variable and dependent variable. Yes. Then slicing, after slicing, we have to create a train and test data set. Yes, it's correct. And then implementing a class, means your model. After implementation of class model, then prediction. It's correct, right? Prediction. So cleaning is required. Yeah, that before, when you upload data set, no, that time you can go for the cleaning purpose. But major part is that without cleaning you cannot do anything. So always go for the data pre-processing. After pre-processing you can do the this concept. Now see what I'm going to do here. Performance matrix means, yeah, performance matrix nothing but your accuracy score. So I think we haven't checked here accuracy, right? Not not So we can do that, right? Wait. So that is a linear regression. Can you tell me about uh, how to check accuracy score? Can you tell me? Okay, I got an error here. Wait. By finding linear correlation coefficient. Yeah, that's correct. See what happened here. Label encoding is there. Yeah, now we get it easily. Yes. Now there we have some kind of structures as well. If suppose maximum time there, we are not getting any problem statement on the basis of regression, but maximum time you will get into probabilistic or means classification based concept. So today even we are going to discuss about that one, means logistic regression. So let's go for the implementation as well. Okay, score implemented here. So you can go directly here. Yes is equals to, what is the regressor? No, regressor dot predict score x test and y test. Check out. So how can you believe on that your model? How can you believe? Can you tell me 93% of accuracy you are getting? Can you tell me about this one? How can you test your model? It's good, yeah, 93 is good, but how can you decide that 93 is in best? Are you getting my question? See, we are not doing only concept of implementing the algorithms. We are finding the some concept. Uh, is it possible if I change the test size? Is it possible that we will get with different answers? Or suppose if I change the random state, check out one example. You can take 1,30,000. If suppose I will take this one. Okay. Oh, sorry. Actually, I have to pass here this whole line. Hmm. I think you will get that data set on internet as well, Rahul. I will check that one. Don't worry. I'll share with you. See what I'm passing here. The way we have to check our data is means profit or less. That's why I'm just passing here. X test you are passing. Is the whole model same as a before for multiple? Yes, yes, sir. There is no difference. Even if you go for model means multiple linear regression purpose, you can use the linear regression as well as the means linear regression class we can use for the simple linear regression as well as the multiple linear regression. It doesn't matter. Okay. So this is from Google. If your X value is between 60 and 70, it's poor model. If your X model is in between 70 and 80, you're good. Means percentage you are saying, Rahul? See, even your model is giving 100%. I can't believe in that model. Why? Yes, sir. Actually, what happens, correlation is 0.93, which is nearly one. So, see, if you discuss about linear regression, no, the point is that, it's okay, we can go with it. But if you are checking your past data, means, uh, if suppose if I'm thinking about your X test and Y test, these are the individual thing that your model don't know about X test and Y test, right? If you are trying to pass that data into the model, if suppose model is trying to give somewhat nearest value, if suppose your model is not giving proper answer, proper means nearest value, and some other related some values, assumptions should be same, but you are not getting proper valuation, you are not getting proper nearest value, and you what happens there, your model is giving 99% of your accuracy. So that time we should have to check about, no, means your properly your model is going or not. Zero error, you do not expect zero error. See what I'm saying, regression will not give you a properly answer. You can class in the classification, you can check, you can expect more accuracy, but in the regression you cannot expect, because this is a continuous value, so somewhat your mathematical functions are applicable there. See here, which data I have passed here, 0 0, this is New York, no, New York. So this is actual profit, sorry. See, this is actual profit, and this is predicted. So 1,92,000 minus by 190. So almost there we are getting 160, 1,060 values, means 1,060, 6,000, 1,600 value. So I think you are making good profit. So your model is saying it should be an 190,000, but your actual profit isn't high, so you can capable. See, the it depends upon the person who is satisfied with the answer or not. Suppose sometimes your client says, I have gained, I have earned more profit, so my model is saying minimum, so I'm happy with it. But your model is saying, suppose 1 lakh, 2 lakh 30, 2 lakh 60, and you are making a profit of 1 lakh 92,000, then somewhat there will be the problem. Okay, it depends upon the mentality of those are means inserting the data here. So it is not achieved its aim. No, actually 2000, it's okay, no, 90 to 92,000. But if you are getting suppose 70, 75, then definitely it is kind of, it should be relate, no, your actual value and prediction value. Is it correct? It should, we should have to relate with the actual and prediction value. See, problems and dependency of the data. If suppose check out what's the output we got here. Wait. See now, the accuracy 99%. With the zero random value, we got a 93% of accuracy, and with the what random state is equals to 10, you are getting 99%. So if suppose if I'm increasing the count of training set, you will get an almost 99 point something. So it is kind of 100% of accuracy you are getting here. So can you believe on that your model? You can believe on that. But if you are saying that tomorrow will be the rain, tomorrow will be the 7 millimeter rain, 5 millimeter rain, it depends upon the actual position, natural positions, right? So this is kind of, you are saying that you can make you can make 1,90,000 rupees of profit. You guys are thinking about more random, more no, 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 not like that actually. If you know, the way you said no. Now I will give you one example, best simple example. I will tell you. Suppose profit is in middle part. See everyone, this is a major point, and please concentrate on the screen. The way we got in question, no, I will tell you. I'm telling you. So what will happen if suppose profit is on middle part? Somewhat what will happen? Somewhat the way you are saying no. Suppose if I'm passing random state is equals to suppose 10, you'll get a profit of means your actual means suppose 100 profit you want no. So somewhat wait I will tell you. I want uh 1000 rupees of profit. I want. Okay, this is actual, and I want that value. If I say random state is equals to suppose 800. So random state, when I pass the random state, your model is giving output as it should be 800 profit, 800 rupees profit. And if I say 15, if I say 15, your model is saying that you will have to give 700 rupees of profit. So what is happening here? Just imagine what is happening here. The profit ratio is decreasing when I increase the random value. Are you getting? Just imagine. I'm not saying that model is doing like this one, but I'm telling you, just always do the some assumptions like this one. So when random state is equals 10, your profit is in getting 800. Random state is in 15, your profit is in 700 rupees. But when I pass random state 5, see, and your profit ratio in between 900. So what will happen? You want 1000 profit ratio, means your actual data is saying, so whatever the spend means R&D spend I'm passing, then I got the 1000 profit. So whenever your model is going to give the prediction, you should get nearest value of your actual data set, actual prediction. So what is happening here? When you are passing random random state 5, you are getting 900. When you are passing random state is equals 10, you are getting 800. So in between data now, sorry, in between data now what will happen? Check out random state. I'm passing 1. See, random state I'm passing 1, and what will happen? Okay, see what will happen. So you have to check out the range between that, on which random state your profit is coming nearest or lowest. Means always whenever you implementing the algorithm, no, you have to take a notebook and pen, and you have to write down your observations. You know the thesis like that the people they have done in the previously. Um you have to do a thesis like that. When I taken random state is equal to 10, I got an 800. When I taken a random state is 5, I get in 1050. So whenever you want to tuning, model tuning. Model tuning is nothing the way you are finding the radio, no. So similar kind of that you have to tune the model. So not only random state is affecting on that, means random state is affecting on your model. Another one thing that will affect, that is in what? Not only random state is affecting, another concept that affects on the prediction. Exactly, test size. So always whenever you are going to tune your model, that time you just make the difference between that. If suppose I'm passing test size equals to 10 and random state is equals to 5, we are getting this one. Test size equals to, suppose I'm passing 10 and random state is equals to 10, what will happen? So you have to tune the models. So within a single hit you will not get an answer. Always you have to tune, always you have to make a difference. Somewhat any very rare case you will get an actual prediction. Very rare case you will get an actual prediction. Means actual means not actual, means nearest nearby value, because your regression you are doing. So regression is comes under the continuous value. So continuous values always changes, right? So you have to make a difference. Tuning, model tuning always going through that. Test size, random state, and not only test size and random state. I think another one thing there we get it that if suppose prediction is not only based on your all the observations. If suppose your client is saying do not go with, if your client is saying do not go with the state, take only R&D, administration, marketing spend, and do the profit ratio. That's it. You have to take only 3 columns and go for the profit ratio, isn't it? That will be affecting. No, I mean definitely they are going to affect concept, because the state column is in categorical data and R&D, administration, marketing spend is in continuous data. So definitely the whole journey will give you some kind of nearest value, because your profit ratio is in continuous data. I have to tune until the profit reaches my target. Yes, see, this is one possibility to reach, to get your target value. This is one possibility. Second possibility is that actually data is your correct or not. Means if suppose you are tuning a wrong data, then definitely you will get affecting. Are you getting my point? You have to check the data isn't wrong or not, and those are the things that we have to do. Then where is an reliability is prediction. If it is already above 1000, he has an already trained himself better than trained. See, it's not meaning to get above, because he want how much? 1000 profit, because this is your actual value, right? Why why we have to check, why we have to check your model prediction is meeting with the actual model? Because whenever I pass other data that is not trained to the model, that time you can blindly predict, you can blindly means trust on your model. That's why you are comparing your actual data with the prediction data. Are you getting my point? Why to go for that? Why to do always means comparison with the actual data? Whenever you pass the custom data to the model, then you can predict. No, then you can trust on your model. He already given the profit ratio actual with the comparison is good. The frequency between means differentiation between is very low. Then whenever I pass the custom data, means that already I don't know the actual prediction. That time only I will find out. No, so I will create my custom data here. Suppose I will create suppose 1,60,000, 1 lakh. Wait. If suppose if I make 1,61,000, 1,16,000, and 2,71,000, and my company is from Florida, and execute. See, so now tell me, how can you believe on that model? Because whatever the data just I have passed into the prediction, that is not from the trained data set. Is it correct? No, what I'm saying? See, everyone, I'm just whatever the things that I'm telling, that isn't very genuine, because The whatever the just I have passed, no, that is not an value of that trained or testing value. That is a completely customized value that I have passed. So how can you believe that model is giving the 1,84,000, that somewhat that value is there? No, you can't believe that value. But believeness when comes, the trusting concept will when comes when your model prediction meets your actual prediction. Somewhat that time. One point you said we compare different datas. Anything else we could do the prevent this? Uh datas. Anything else we could do to prevent this? Preventing means what to prevent? Like means you think about other data. If suppose checking the model accuracy or checking the model is going good or not, you have to check on your own data set. You cannot go for the different data set. Is it correct? No. If suppose how I know, if suppose how can I find out that whatever the data just I have passed, whatever the data I have passed, that is giving correct? So you have to check for the original data set. How can we avoid so it doesn't go above 1000? See, that's the thing. I got your point now. Doesn't go above 1000. So that's why I told you, no, you have to go for the model tuning. Model tuning means you have to tune everything. Within a single hit, you will get your model is going upper side or downside. See what I'm saying? If suppose you have passed here, test size is equals to suppose zero point 0.3 and random state is equals to 1, what will happen there? What I'm saying, within a 5 minutes of execution, you will get to know that your model is going above or not. So once you got that your model is going above, you have to check about that. You just try to reduce the some values or try to increase the some values. If suppose the things going wrong towards the testing and training, what will happen? You have to check your data set. Why? Because if suppose somewhat your data set is giving you this state column concept, then what will happen? Are you getting my point? Yes or no? Okay. So we do one thing here. Wait. I'll take the duplicate copy of this file so that we can make a difference between that. But I will make the different copy of this file. Today, we are going to learn about some facts related with the logistic regression. Means some concept related classification problem statements. As you work in this industry, what accuracy do you get while working, and what's the acceptable above 90%? 90 means 90%, no? Accuracy. Percentage you are asking for that. See, the previously already I said you that if suppose your your output, your prediction value, it meets your actual prediction, somewhat meeting, somewhat. Okay. So you are satisfying, no? So what is going on? Means you are satisfying with your answer. Why? Because this is going on. But what will happen? you will get an 50 to 60% of accuracy that time. And 60% accuracy, you will get suddenly, my model is good, my model is everything is good, my model is giving proper answer, and then also I'm getting a 60 to 70% of accuracy. What will happen there? So what is the drawback that we get? Sometimes your data is not enough. Sometimes what will happen? Your data is not enough towards the model training. You have to train more data to get an means 70-80% of accuracy. One of my colleague is there, and some of the students also, they are getting 16 to 70, 17, I'm saying 20, 22, 24 kind of accuracy they got. So what will happen? That's why I'm not believing on accuracy score. Why? Because the whole journey you are doing a 99% of work, and within a 1% of that point you are getting a 70%, 99%. The way I said, credit card fraud detection is an imbalanced data, but when you pass the accuracy score, no, you will get a 99% of accuracy. How can it is possible? So you say that that is a classification problem. Then classification should be work properly, no? In regression you will get a problem because continuous data calculation problems will get into regression. But why to get problems in classification? Because completely sorted concepts are there. Whole the process is in categorical process, and then also your observations are wrong. See, the way I'm just telling you all, I think definitely you will get so much to think about it whenever you get in some kind of percentage, means a hiring percent, lower percent, how to believe on that model, how to go for that model. Always check about your uh, this looks like a common problem in ML. Then if somewhat we are close to actual just believe. Yes, machine learning is an, it's kind of robot. See what I'm saying? We don't have to rely on the accuracy only. It's a part. Yes, yes. Accuracy is just a supporting actor. They give you to some believance with means it's kind of try to trust. The accuracy score is saying whatever the things that you have done, please try to trust on that. That's the thing of your accuracy score. And the means the way you said, no, this common problem looks like a common problem in machine learning. What will happen? Machine learning is a robot, no? What is the meaning of that machine learning? You have to train the machine, then your answer will come, no? So machine learning don't have any kind of emotional intelligence there. He only knows that whatever the training you have done, no, that's the only I will give the answer, because that behind the scene is in completely calculation. So emotions that comes under the us only, means whatever the people, whatever the we are there, no emotions we have. We know that where is an problem, comparison and all. So ML is always based just give me data, go for the prediction. That's it. Now I'm just wait. Hmm. See what I'm going to do here. I'll take only If I pass here, instead of taking state column, what I will do here, I'll pass here 2. Okay, so you know that -1 is in profit, -2 is in state column, and these are the R&D, administration, and marketing spend is, and these are the 3 columns that we are passing into where. Is it visible now? Yes. So let's check out your data set. Not sure if I'm true. Is this how benchmark scores predict? Then means you're thinking about some sort of um, means 70% or 80% means certain. See, I always prefer for the your prediction should be go above the 70%. Always. Why? But with that I'm checking with the actual value comparison with the prediction value, actual prediction. But always I prefer for the above 70 because you can, the human tendency is there. If suppose if I'm getting 20, 30, and 40, then even your accuracy give means your prediction values and actual values are same, then also you will not believe on that when you are getting 80 to 40 and 50% accuracy. So always believe, go for 70, 80. Okay, 90, 99% is an, if suppose your model is giving 100% accuracy, no, that is wrong, complete totally wrong. Okay, are you getting my point what I'm telling you? See what I'm passing here. I will come comment this one because I don't want that. Executing the work. The comparison purpose, I have copied this file to here because the first part that I have taken here multiple, and second is in this one. So see, the model is trained with the x now have only 3 columns. Okay, do not worry about it. And mm, so we should have to remove this one because state column we don't have. That's why. How much accuracy we got it here means this is 1,84,000. So I'll copy this value and paste it down here because that this answer comes by with state. Okay, correct? No, you got the point. What I have done. Only 3 columns I am passing here. See how much difference we got. 1,83,000. So with with state we are getting 1,84,000. Without state we are getting 1,84,083. And what is the actual prediction we have? Actual one. Okay, sorry. Wait. I have added customize. No, see now what is happening here. So with state, without state, see 1,92,000, that is in your actual prediction. This is your actual prediction. Okay. And this is your with state prediction. Are you getting my point? What I'm doing here? Yes or no? In the previous part, in the previous means with state when I passed no, that time I'm getting accuracy this much. See here. So 1,90,000 is an with state column. State column is in categorical data, no? Is it correct? State column is in your categorical data. So only one column is in category and other columns are continuous. So what I have done, I have removed that state column in this algorithm. Means here also I'm using multiple linear regression. Only thing is different here. I don't have passed any kind of state here. See, check here, check out here, state column. And what I have done with the state column and without state column. So with state column, I'm getting 1,90,777, 74, and 1,91,705. So without state and with state, who is the nearest value you are getting here? Without. Yes. So actually, see, what is the meaning of telling you guys? If suppose who is the person, how much affecting concept is happening here. If suppose your client is saying without state column, you go and check out the accuracy, you have to tell them that with state I'm having this much, without state I'm having this much. If suppose I'll pass here, I'll remove this, okay? Not an issue. I'll remove this one and pass here X. Oh, what happened here? See, accuracy is increased by 10 points, some around. Is it correct or not? See, previously accuracy is 99.1 and now you are getting 99.17. So 16 points are increased. So now tell me, how can you believe on your model? You say that I'm getting a 99% of accuracy. So it depends upon us, no? So which model is best, which model is not best, kind of things that will happen. It is not defeating its purpose by removing. Accuracy is not changes, but your accuracy somewhat changes. But you know the output, what the prediction that he has given, that is an nearest value he shared. He given you a nearest value, no? Yes or no? So this is completely based on the observational means model tuning and observational your returns means if suppose you are doing the multiple linear regression, you have to write down the each and every observations in the project. Just see, this project name is in 50 startups prediction means profit prediction project name. Whenever suppose if you are working on that project, you have to write down each and everything with the profit, with the test size. I'm getting this one, you have to make a chart of this one. So test size is in 0.2, random state is equals to 10. I'm coming with the nearest value of actual prediction. So if suppose you are getting very means very high difference between the actual data and prediction value, then why to write that data into the your notebook? whenever your prediction comes nearest to the actual value, that time you write it down. We are getting now. I'm just near to the actual prediction. So then you can go for the assumptional concept. Then you can go for the model tuning and write it down everything. And whenever you go for the explanation to the means interview purpose, that time you are completely fearless to explain. Why? Because you know the complete internal part. If suppose you are trying to go for the I have checked the intercept, I have checked the slope, so I know the model program means I know the formula. So what will happen? Your interview will not ask you any question. Why? Because you are telling them directly formula. And the way the 90%, see what I'm saying, 90% your general behavior is important, means general knowledge is important. So how we can go? 10% is your model, 10% is your algorithm, 90% is completely whole journey, what you have learned. So at the end, what's the best fit according to you? 19, no. Now means in this project I will go with the 99.17 happen, no, because that comes under the nearest value. And what is the definition of regression? What is the definition of regression? The relation between the continuous columns. That is important, no? The relation between the continuous columns. So y2 pass, I'm y2 go for the categorical data there. That makes the difference between two. If suppose three categories are there, 110, 20, 30. So check out the difference between the 10, 10, 10's difference. If you are passing this value into the regression formula, then definitely that will affect. So do not believe on the categorical data when regression you are doing. Are you getting my point, guys? Actually, see, this today's session is the most important. That yesterday's session also we have done very well, and this session also the way I have implemented. Now, I'm going to give the introduction as well as some problem statement with the logistic regression as well. Okay, so you know, go for the multiple linear regression model. Go for the some once we cover up this concept, will whenever we get in time, that time we'll go for the implementation of some other data set as well. Okay, but we will go for the completion of our other algorithms as well, understanding, because many factors are there to understand, not only implementing the algorithm, but also we have some sort of techniques problems, huge problems actually. I'm not saying that your every journey will go into the right direction, no. This ML journey is not good. Means every time you have to think about my data is correct or not, my model is correct or not, model tuning is good or not, my accuracy is coming like this, then what is happened in between the journey of that execution time. So whole journey is important. So every time you have to think about the every factors, every stage and all. If suppose if I'm passing four columns, what will happen? If I'm passing two columns, what will happen? On which data is affecting more on the data set? That is also important. The way categorical data is affecting, and your that when I remove that categorical column, your model gives some one another nearest value to them. So just think on about it, how the data is working. And it's not like every time you are getting same data. If suppose you are working in the same company and same company is providing a same data throughout the his whole journey, then it's good, because you are learning that data. You know that the structures, factors, product ID, products, all the things. That time you will enjoy that machine learning. You will create your own model, and take that data, pass it down, that's it. You will do only these things. If suppose you are working with some service based company, and that service based company is taking each month, each 2 months, each 3 months new data set they are taking, each time they are getting new clients, then definitely you will get an headache. Why? Because you have to understand their behavior of your data set. No, are you getting my point, what I'm telling to you? Means what? Every time when client changes, your behavior changes, your data set behavior changes, everything is changes. But if you're working with the single product concept, like suppose WhatsApp companies there, WhatsApp data set is a single behavior, no? So whatever the peoples are updating status, if peoples are doing some work, you have to work on only WhatsApp company's data set only. But if you go for a service-based company, those are in the vendor level, or mid-scale company, small-scale company, they are getting each 3 months, 2 months new client, freelance concept based. Okay, so that time you will get in more headache on that time. So better, why not you put your time now, learn something new. That time you will get less headache will you will get. Will the client tells which column are affecting the result and target? Uh, See, sometimes your client says, sometimes you have to take yourself. Means suppose the way I already said that weather forecasting, if suppose prediction purpose your three columns are only affecting, see what I'm saying, prediction purpose only three columns are affecting, then you have to take only three columns. And client is saying you have to take a straight column as well. Yeah, you have to, but you have to tell them about what is the difference you are getting here with this one and without this one. Sugar mill, sugar mill concept, there we have in the sugar mill date, there we have the some kind of means every year peoples and their land sizes changes. Is it correct? No, in India sugar mills are there. So every year the mills land, means those are the peoples, they are connecting with the sugar mill, no? Every year, every 2 year, every 3 years, their owners changes, their land means divided. If suppose your land is there 100%, they are divided into the 50-50%. Every year something is going on there. So every year, if suppose sugar mill has, and suppose sugar cane is there, no? So sugar canes means that require will changes, every time changes. So you cannot believe on the same structural point you are getting here. If suppose your data is coming on the January, or your data is coming in the winter season or summer season, because you know that summer season comes, what will happen? Heavy, means the temperature level is high. That time your model accuracy, means your data is changes, data behavior is changes, your model accuracy comes down or comes up. So you have to know about this one. I think whatever the things that I'm telling you, know that isn't completely general. Is it correct?
Hey, how are you? This is Rahul.
Hi Rahul.
How are you, Abhay?
Yeah, I'm fine. How are you?
Yeah, good, thank you. My
Yeah.
concern is if we're getting 99% of trained data,
Mm-hmm.
that means it's already fitting exactly against what we are training, I mean, what we actually have. So it means it's not performing with the data, with the algorithm that we are told him to perform. So it's defeating its own purpose if we already having the same amount of data, if it's 99 or 100%. That is too close to the already the data we have.
Mm-hmm.
So that means it's not performing the prediction that it was intended for. So how we can, overcome that? Because it's already
Or
too closely to the 192, the one you explained earlier.
yeah, just
To
if
me,
suppose if you
to
are,
me, that is not correct. Can you see if I'm wrong? Can you tell me how?
means you are talking about this example.
Yes.
Okay. So what is happening here? The whole maximum time your prediction value, actual value, that is an G. See first. Here you have an two options. The first option with the state, without. Second option is without state. Okay, two different options are there. What will happen? Always there is an some assumptions that if suppose your without state prediction is meets to the actual prediction, because there is a nearest value, no, so what kind, how much difference we are getting, near about 1600 years, how much difference we are getting here? 7, only 500
Yeah,
is
it's
difference, right?
about 500 years.
Yeah, only 500 is difference.
So
And
that means
so
it's very closely aligned to the actual data. So that's not performing its task. That's what I mean. So we should have some other ways or some other things. That's what I'm thinking, but I don't think this is correct. I might be wrong, but this is what strikes in my mind.
uh, yeah, actually what will happen, if suppose it depends upon the many factors, not I'm telling you only one factor, because I changed their state column, because without state column you are reaching towards the actual value. Okay, you are telling to your client that without state column I'm reaching towards the actual prediction, but with state I'm getting this much difference. Are you getting the satisfaction concept that comes under the client phase? You have done your work with state, without state. You can believe, actually in my believance, if suppose without state is good. Why? Because state column is your categorical concept, no? So categorical data always makes a big difference in the prediction part. Is it correct? Because if suppose if I'm thinking about continue, if suppose state column is not there and another continuous value will be there, then it's okay, and I will check that, means difference, means if minimizing the difference is my work only. And which state column is going on there, which state column, it depends upon that one, that person who is giving you the work about this one. You have to tell them that I'm getting this one is a difference. Use so where we will cross that data, it almost same, so close. That's good, no? You have that close difference between that. One is giving lower difference and another one is giving little more difference. Okay, higher difference. So you have to tell, see this data set here, that's why we are getting lower and higher, means somewhat fraction of some difference. But when you go for the other data set, now you will get a big difference. That time you will definitely decide, you can you will not ask me as well, you will decide yourself that that isn't, because 1,91,000 is nearest to the 1,92,000, then I will go with the without state as well. So you have to tell your client that this is the difference that we are getting. This is the closest thing. If suppose another one, some difference I'm doing, can you please plot this data on the screen? Means plot means visualization. You are saying? Yeah, we can go for this one. Actually, this is a multi-classification, no? So why not we use here? I think 99 is good for this data, as we removed categorical data. It's not imbalance data, so the data equality is good. Yeah, actually, now the regression concept we worked, means actual regression. Actual regression says that you always need a continuous data there. But I will not believe on that 99% concept. Let's we take for data that value. I never plotted that one previously. I have to implement this, try to implement this. Let's go for this. Wait, I will take that code directly. Actual and predicted visualization, please, so we can see it. Yes, yes. I will take that simple linear regression data set, so directly we can go for the passing the data. Screen is visible, no? With the Seaborn also, I will check for that. White train data set. What is the error? X and Y must be have same size. Okay, okay. So prediction purpose, I have to do one different thing here because we have to do one thing. Wait, something is Just a bit. I'll go for, because what will happen here, the implementing the x-axis and y-axis. If suppose if I pass the implementing x, three input variables will not get properly here. So implementing purpose will get a problem. Mm, Rahul, I will take this time because we have to make a three columns are there, no? Are you getting my point? Three columns implementation a little bit tough here. Yeah, three columns and one column will be there. So plotting three columns with the one prediction value, you will get a little bit problem here. So instead of spending on time, I will go for work and I will upload, or when we come no in second session, that time also I will do that because I have to work here. That's why instead of spend here time. Don't worry. But I think maximum concept you got or not. Everyone, I'm just asking to you all. The means exact means not an assumptions. Now whatever the things that we have discussed, no, that these are the assumptions. Means which value is correct, which value is not correct. These are the things that we have discussed, right? And checking with the accuracy comparison with the actual data, that matters always matters. So whenever you go for suppose visualization concept, or you always think about your output is meeting or not, your output prediction is meeting with the prediction or not, right? So maybe whatever the things that you have worked on the multiple linear regression, that always matters, and go with the study. And I'm just passing here some concept that what you have to learn. Definition, okay, formula. Formula will not ask by interviews, but if you know that, that's good. Formula definition, advantages, disadvantage, working, project-based explanation. So these are the things. If suppose there we have the any kind of algorithm, you always know about this definition of algorithm and formula, advantage, disadvantage, working. Working means you have to tell them that whole process how it is working. And project based explanation means whenever you will get an a telephonic interview round, or you have to know that because you don't have any kind of structural part in front of you that time. So always learn about first to last till now, so you will get easily get it. So can I go for classification concept and some drawbacks? Okay, so when I come to the uh, classification concept in next session, no, that time I will come with the PPT as well as explanation of logistic regression, whole just journey of that. But today and now I'm just going to discuss with you some points. See, classificational concept is nothing but you are going to predict a categorical data. The way you have done the journey with the continuous data, in the classification you will get an categorical concept, means predicting a categorical concept. So there we have the imbalancing concept as well and cross validation concept. So do you know what is the difference between imbalancing and cross validation problem? In the interview definitely they will ask imbalancing problems and cross validation problems, that always comes into the classification technique. Anyone knows about imbalancing? Already we have discussed. Imbalancing means your prediction values kind of bias. Bias means, you know what actually? That is, wait, I will tell you one thing here. See now, what is the major thing that we have discussed? Imbalancing kind of bias. Biasing is a problem, no? Means biasing is a problem. Imbalancing is also problem. Biasing concept that the majority of categories always gives the answer towards that majority category. Okay, means model gives you the output towards the majoritical category when we learn, when we train to the model. So here we have the 400 rows and data set is and social network ads. Okay, so social network ads is nothing but the age column is there, estimated salary is there, and purchased column is there. See what will happen here. Just consider about that. Just do the assumptions that 19, the age is 19, estimated salary he has and 19,000, and he is able to buy a car or not. This is probability you are having here because you are going to predict this person is going to buy a car or not. So purchase column has in two categories, that is in 0 and 1. 0 is saying he cannot purchase, and 1 is saying he can purchase. Okay, so these are the 400 peoples are there in the different age level. The 35 age is there and 20,000 salary is there. He will not purchase. 26 age is there, 43,000 salary is there, and he will not purchase. Kind of things. And in the downside also we have, there we have the 49, the last row, 399 row. Okay, 400, sorry, 49 age is there and 36,000, but he can purchase the car. So this kind of probabilistic answer is there. So whole data set we got it here. This is collected by the survey of the peoples, and now what we are going to do, we are passing age and estimated salary to the model, and he is going to give the answer that he can purchase or not. Means he will purchase or not. Is it correct? Are you getting my point? Means on the basis of age and salary, you are predicting the person can purchase car or house or anything. These are the things that we have. So what will happen? Even you don't know that how many yes means true data is there, how many false data is there. It's kind of probability, no? So that's why. If suppose if I go for something like suppose data set of, so how many unique 0 and 1, right? With the 0 and 1, I will pass value and counts. So check out, zeros are nothing but 257 and ones are nothing but 143. Just imagine if suppose if I pass this data into the directly to the model, means the way we go for the splitting a data set into training set and testing set. When I pass, you know that already model is getting biased towards 0. Why? Because how many zeros count is there? How many people they already data set has how many people they don't, means they cannot purchase car. 257 people are there and 143 people are they can buy. So model learns maximum people those are having 257 people, no, those are can't buy any car. So max he goes learning, means the count that we have here, so always towards the maximum peoples. But in this data set we don't have in that much heaviest difference, but 100 count, check out the difference, that zeros and ones, 100 count difference we have. So what will happen if suppose if I'm having hundreds of count difference between that, and whatever the answer will come, no, how can you believe on your model that because he learned 257 count of not, 143 is count of yes, because he learned so much things. So model is here your imbalanced. So model is imbalanced. That time you have to solve that. Solving the model imbalancing, there we have the three types. That is an oversampling, undersampling, and what? Third one, smooth. Smooth. So now the question will rise here, because the way we have the imbalancing model technique, what is the work of oversampling? Because when we come now coming sessions, that time first implement this kind of structure we have to learn, because interview questions will get first how to solve imbalancing techniques and where to get imbalancing concept. Imbalancing problem will get into the classification algorithms only. Why? Because you are having the classified prediction values, categorical prediction values into the classification. That's why you are getting this problem there. Is it possible that we can use this concept into regression? No. Yes, correct. Right. So we cannot use. Why? Because there we have the multiple continuous values. If I'm going to use oversampling there, what is the work of oversampling? What is the work of oversampling? Oversampling do, those are in the minority, those are in the minority, he will increase the minoritical count till majoritical count. I'm not getting Rahul. No, actually, how can we use? Because the prediction values is in categorical, no, in classification, and regression you will get in continuous. So yeah. So means if suppose if I'm going to solve this problem, because see, one thing do not forget, imbalancing problem comes before creating testing and training set. Whenever if your interviewer is asking no imbalancing problem when it comes, probably that problems comes in the two ways. First one is before the training set, after the training set. Before the training set creation, that is imbalancing data. After the problem will come, no, that is nothing but cross validation. So cross validation I will tell you when it comes. But if I'm thinking about imbalancing problem in a classification, they're solving the techniques that these are the oversampling. Oversampling comes that increasing the what? What is the oversampling? Those are in the minority, that will increase till the what? majoritical count. If suppose your 1 is an 143, your count will increase till 257. So he will increase the 357, 257 means one's account will increase till 257. So what is the drawback? What is the drawback? You are creating a random values, no? Means you are creating increasing the ones, then definitely side by side you will increase the X data as well. Is it correct? No? The way you are increasing 142 to 143 to 257, side by side you are increasing the X data as well. So just imagine if suppose one's count isn't suppose 10 to 15 counts are there, the way we have discussed about credit card fraud detection, there we have increased 492 fraud data and 284,000 true data, true transactions data. So fraud data is increasing how much till 2 lakh 84,000. So that is oversampling you are telling that. So oversampling gives you the raw data, means it's kind of huge amount of data you are getting. So you guys are saying that if this is making the problem, why to use? You know that getting the problem. Your model knows that getting the problem, but model tells you give me the only prediction values are I need only prediction values equal form of count. That's why you are making here. You know that he is creating the means redundant data there. Okay. Now the second thing. Then the difference between same between two means undersampling oversampling. Over and under, right? Undersampling, oversampling is increasing the count. Those are in the minority. Undersampling decreasing the count means who is the majority? No, he will decrease the count till the minority. Even here also you are not going to believe on that. Why? Because he removed himself some amount of data from that. So it's kind of 257 to 143 means you are passing 143 data to the model. He is losing some amount of data. Means if you think about that, why my model is not learning all the data, or in the oversampling minority go to the up, and so 257 will not affect. Yeah, when it will not affecting affection that will happen into the model. 0 is in 256, 257, and 1 is in 257. So now the whole journey will goes there, no? But if suppose you are stay with the minority and you are passing the majoritical count, then model learns majoritical data maximum. So model tries to go with the majoritical answer because he learned so much things about majority. You know what? Now I'm discussing about one thing here. Now I'm discussing about one thing here. That is, if suppose not the thing about making a equal part, not the thing about making the equal part, you are doing one thing here. You are passing equal part, and when the testing and training part will come, no, there also you are getting the problem. So just satisfy with the equal part, means whatever the making the oversampling, undersampling or smooth technique. So undersampling, you know that undersampling doing this minoritical concept means that count will decrease till how much? 143. Are you getting my point? Minority will majority will decrease till the minoritical concept, minoritical count. So what will be the problem? This will match with each other when applying the oversampling. Rahul? After applying over and under. Oversampling and undersampling or smooth. If suppose three of you are using the work about this using this imbalancing techniques, balancing the count is the only work. At the end, you have to make a same. If suppose if I'm using oversampling, if suppose I'm using oversampling here, wait, I will show you. After, before and after I'm showing you, so it will be helpful to you. Yeah, count will be same. Check out the count. See, oversampling, you know that. Undersampling, we got it, that minoritical value. In the smart also, we are having. But maximum time smart will work on the multi-categorial data. Are you getting my point? Multi-categorial data means more than one categories. Are you getting, guys? More than one categories. There will be the drawback. Yeah, every concept has a drawback. Oversampling has a drawback that you are increasing the count randomly. Second one has a drawback that decreasing the count, you are losing the data. Even smart is also increasing the count. But what will happen? He is increasing randomly pick upping the any kind of, means those are in the minority. He will increase the randomly having exactly same values copied. Yeah, exactly same values. Only one, means if suppose one is in minority, he will increase his own count 1 1 1 till majority. Oh, smart is nothing but what? Synthetic. Synthetic is nothing but artificial data he is increasing randomly. So more than one, suppose there we have the kind of two, and two is having, suppose before two is having suppose 100. So at the end of the applying the smart is like 257. So randomly he will increase like that. So multi-categorial is in smart, and undersampling, oversampling, you can go for the binary classification concept, right? So this will helpful to you. But now just give me another 5 minutes. Okay. If suppose if I'm using oversampling and I used oversampling, my data is now equally, the count is we are having now equally. Now the check the difference now. If I pass this data into the training set and testing set, you know that X data is having 256, sorry, X data 256 plus Y data 256. What is the total? I think 500 uh, 512, right? 512 maybe. So just check out, if suppose if I'm having 512 data total, and that is going to divide into test size and random state, means you are dividing your data using test size and random state. So that is possibilities, no? You are, if you are passing here random state is equals to 10 and test size you are dividing, just imagine, I will explain this here. Okay, I will explain this here. So now your data is having this one. So can you tell me, I will make, how much data? 250. So I'll make here both 250, 250. Okay. So what is the 20% of test size? Can you tell me what is the 20% of test size? How much? 100? Is it correct? Train is in 400 and test is in, is it correct? And this, just check out, if I make this one, what is the probability or what is the possibilities that your 0 and 1 will go equally in test size and train size? Is it possible? This is suppose y train and this is also a y train. Total y columns data is in 500. Total y columns data is in 500. So you know that your complete 0 and 1 data points are divided in x and y. Sorry, y test and train. Okay. So complete 0 and 1 data points are divided into the x, y test and y train. Can you tell me how can you judge your data? So y test with 0, if suppose I'm getting 30, y test once I'm getting 70. So y test total size is how much? 100. Okay, you are applying the 20% of test size, and y test 0 means y test having zeros count is in 30, ones count is in 70. The remaining count that we are having here, y train, how much? What is the remaining count now? Tell me. 400. What is the remaining count? Here 70 zeros. And what is the remaining now? Ones count. No. Actually, 30 is 0, no. So 250 minus 30, that is how much? 220. And 250 minus 70, that is 250 minus 70. How much? 180. Oh, yeah, right. 180. Yeah. So make a total of this one. So it should be in 500. Okay. This total 30, 70, 100, and this is 340. Okay. This is correct now. So now tell me, your model is now. So which part you are going to train? Are you getting my point? Which part you are going to train to your model? Because here the completely imbalanced data you are having means when you are going to make a train test data, that time you're training and testing how much data you are getting the see. So here is also balancing imbalancing concept that's going on. No, means while taking the data into the model, while taking the data, if suppose you are loading the data, that time also you are getting the problem that imbalancing, and that's solved by the oversampling or undersampling. But when you have made using oversampling, you have solved your problem using oversampling, what will happen? What will happen? You are going to make the training and testing set, that time you, even your data is equally, then also he is getting imbalanced. Why? Just check out. Let me just know, when you are going to train your model, are you passing y test or y train? When you are going, you're going to train your model, what you are passing? Y train you are passing, no? So just tell me, you are training 220 zeros and 180 ones. Here also you are coming with the imbalancing now. This imbalancing is nothing but cross validation problem, and that above, when you are taking the data set imbalancing, that imbalancing is indifferent, and this imbalancing is different. This imbalancing says cross validation techniques you have to use here solving the problem. And whenever your interviewer asks you what is a cross validation, where it comes, you have to tell, while doing training and testing the model, that time in cross validation problem comes. When imbalancing problem comes, while taking the data set in starting of the phase, that time you are getting the imbalancing problem. Is it correct or not? Are you getting? 30 and 70 y test. Anyway, we can split into the 50-50, or he does his own. That's why we have to use cross validation concept here. The last point. Okay. When I'm telling you, when I load the data set, we are getting imbalanced problem. Okay. So solving the imbalancing problem, we have oversampling, right? When data loading point, when I load the data that time. Okay. So using oversampling, I have solved that problem. Means I made equally. So second part, what I will go for making training and testing data set. Training and testing data set. That time, what I have made, test size equals to 20% I have made. So automatically train size is 80%. So now your complete process is how much? Y test process is how much? Y test is equals to 100%, and Y train is equals to 400. So here also imbalancing comes. Why? Because you have passed 20%, and because of that random state, you are picking up a data randomly. So data randomly picking up means what will happen? You are passing into the randomly into the y test, y train, y test, y train. Even model don't know. Model only says that you have said me 100 points you have to pass into y test, 100 400 pass into y train. How? Randomly with the 10, means random state is equals to 10. So Randomly he is picking up y test, y test, y test, y test. Even he don't know that I'm picking up equally or not. So sometimes he will pick up like a one continuously. So that's why there we are having 17 y test and 30 in how much? Ones count 70 and zeros count 30. And y train, zeros count 220 and ones count is 180. So this is the major thing that we have. So we have to make equally. So solving this problem, there we have the technique that is an leave one out technique, stratify technique. Okay, these are the techniques we have to use and solve it. Too much to do having headache now. Actually, you know what? Too much means you have to see the way I'm telling you. No, this is very easiest work means I'm trying to give you some sort of journey of this one. But every time I always try to go for some model based example. Means first we have to do like this one, secondly you have to like this one, the concept. But anyhow it will not affect because minority is equal now. Yeah, when you go for the see, this part is saying you in balancing. This first part is saying you in balancing. Second part you are telling you that is an cross validation concept. Here we having the first one is an leave one out and stratify technique. Already I told you stratify. Is it correct? K-fold technique. Stratify K-fold. And third one is an sorry, K-fold. Okay. So the first part is telling you that data imbalancing in your original data set. And second part is telling you in balancing, but when training and testing, model making time, when you are going to train your model now, that time you are getting here in balancing. That's why here making the balanced data, you are getting having here cross validation concept. That is an leave one out K-fold, stratify K-fold. Still, I haven't explained you leave one out. Still, I haven't explained you K-fold means what. So do not go and do not worry about this one as well. But I'm just telling you, imbalancing comes in the two ways in the algorithm. First, in that, when loading time, and second, model making time. Now got the point? Yes or no? Today is a little bit scrambled things. So many questions you guys asked me, but I always try to give you answer. Hope so. Some points are remaining, but I will try. Can you please upload the video today itself? Actually, that is not in my hand, but definitely they will update. No problem. Definitely, 100% they will update the notes also. Yeah, thank you, Rahul. Yeah, actually, I will upload these files as well. Means the way we have discussed. No, these are the files that I am upload that one tomorrow. Actually, Monday. PPT is also upload. That is remaining. PPT I have created, that simple linear regression. Yes. Hope you enjoyed a lot. And till then, take care of you all and see you on next Monday. Sorry, next Saturday, Sunday. And thank you so much for joining. See you. Bye bye.